All right, second lesson, solving inequalities. Now, guys, what you're going to realize right now is a lot of the rules are the same for solving equations. So here, we're going to solve for t, but we have to get rid of the -3 and the -4. Let's start by getting rid of the -3 with inverse operations. The opposite of subtracting 3 is adding 3 to both sides. We're going to get -4t and -19 plus 3. -19 plus 3, they're different signs, so we subtract, we get -16. All right, now we're going to divide. Now this is the new rule. If I was going to divide with a +4, nothing changes. But because I'm dividing by a -4, okay? When you divide by a negative number, the signs are going to change. This -4 divided by -4 is going to make a +t. This -16 divided by -4 is going to make +4. Now, when the signs change, this sign flips. It also changes. So guys, the answer for this problem, t is greater than 4. That means the number for t has to be greater than 4. So numbers that are greater than 4, 5, 6, 7, 8. So on the number line, it would be an open circle going to the right, greater than. Okay? And that's it for that example. Now, sometimes they can look like this. Now, when you have parentheses, you should distribute. So you get 4 minus 4x. We get 16 minus 4x. Okay, we have two x's here. Now, in this case, whenever you're solving for x, you should have one x on one side. So I'm going to move this x over with inverse operations. The opposite of subtracting 4x is adding 4x. And what happens is this. The 4x's cancel out on both sides, and you're left with 4 is less than 16. Now, there's no x anymore, so there is no one answer for x. Instead, when you have this happen, you have to ask yourself, is this statement true? Does this statement make sense? Is 4 less than 16? If this is a true statement, a true inequality, then your answer for x is all real numbers. If the sign was flipped, if this said 4 is greater than 16, this would be a no solution because it would not make sense. It would not be a true statement. So that can happen when the x's cancel out. Okay, let's move on to the next one. Okay, again, you have to distribute. So I get 3v minus 12 when I distribute. 5v minus 24. Again, you don't want two variables on both sides. I'm going to move this one by using inverse operations. This one will cancel out. You're going to be left with 2v minus 24. Okay, I want to move that 24. So I'm going to add 24 to this side. And the reason I add the 24 is so the v can be by itself. I want this letter to be the last thing here. So I end up with what's left with 12 is greater than or equal to 2v. Okay, last step here. Dividing. I gotta divide this by 2. So when I divide it, the 2's cancel out. I'm gonna get v on one side because those 2 will cancel out. But now on this side I get 6. So I have 6 is greater than or equal to v. All right, next. Oh, right, sorry, number line. For the number line for this, you can put two numbers next to it, like 5 and 7, when you draw it. Okay, so you're going to have a closed circle in this case. And now, what does this say about v? V is what? Less than. Less than or equal to. So less than goes left. This way. All right, now we can go to the next one. Right here, we're going to distribute. Again, we have 2x's on both sides. I'm going to move this one over. And now they cancel out. You're left with this statement. There's no more x to solve, so you have to ask yourself, what does it say? Negative 6 is greater than negative 9? Is negative 6 greater than negative 9? True or false? This is true. So this is all real numbers. If it was flipped, you would put no solution. All right. Okay, let's do 2 more examples and then we'll be done. All right. Here, we're going to distribute the 2. So you get 2k plus 8, right? Remember, both of them multiply by 2. Okay, 2k minus 3k, that would be minus 1k. Now, I didn't cancel it out because they're on the same side. I had 3k and 2k both on the left side. I'm not moving them over, so I'm not using inverse operation. I just put them together. 2k minus 3k minus 1k. All right, now here, I have an 8. Got to get rid of that 8. I get 14 minus 8. I get 6. Okay, now this. You do not want the negative 1 here, or a negative at all. If you ever have a negative k, you divide it by negative 1. That'll cancel it out. And because you're dividing, you're changing the signs. This becomes a negative 6. So this sign is going to flip. That sign is going to flip. So your answer for this, negative 6 here, negative 7, negative 5. What does it say? K is greater than negative 6. So I'll do an open circle, and the numbers that are greater are to the right. So negative 5, negative 4, negative 3, those numbers are greater, going this way, because they're heading in the positive direction. Eventually, this will get to the positive numbers, and all of those numbers are greater than negative 6. Okay, one more example. Here we go. Again, we distribute. They're distributing a negative, so be aware of that. Okay, I'm going to move this number over. So I'm going to do plus 2s, plus 2s. So I get 4s here. Now I want to get rid of the 16 to that side, so I'm going to do plus 16 to that side. I'm going to get positive 4, because negative 12 plus 16. They're different signs, so you subtract. Okay, I'm going to divide by 4, but I'm dividing by a regular 4. That means the signs aren't going to change. This will stay a positive, and this will stay positive, so the sign doesn't change. So you get the answer that looks like this. S, the letter S. I guess I should have clarified that. All of these were S's, by the way. All of those were S's. S is greater than 1. So on my number line, it's an open circle. S is greater than, goes to the right. And that's it.